So let's see question 9 from October 2023 paper. So this is basically from integration, finding area by using integration, part of calculus. Okay, so the first question in part A. Okay, at first you can see there is a figure of the curve C and line L and a region R bounded by C, curve C, line L, and the x-axis. Okay, fine. So the equation of the curve is given there. Okay, the first question. Find using calculus the range of values of x for which y is increasing. So the range of values of x for y for which y is increasing. Okay. So if you want to show that a curve is increasing, so we need what? We need to show that the gradient is positive. So for finding the gradient, we need the derivative of the y. Okay. So let's differentiate the equation of the curve. So at first, a bit simplify the equation, not simplifying, just taking out the powers of the variables and then differentiate it directly. So dy over dx, that would be what? 4 over 3 x negative 9 over twice of x. So that's what? X inverse half. This is the derivative of the curve C. Okay. And we need to show that the range of values of x for which y is increasing. So for increasing dy, for increasing dy over dx should be greater than or equal to 0, right? Okay, so what we can write here, 4 over 3x negative 9 over 2 square root of x, they should be greater than or equal to 0. Okay, so now use critical values. If you use critical values, 9 over 3x, is it 9 over 3? 9, sorry, 4 over 3x. 4 over 3x negative 9 over 2 square root of x would be, I think in this case, you don't need the critical values. You can directly keep working. Would consider critical values if it was a quadratic equation. So let's ignore. Greater than or equal to 0. Multiply both sides by square root of x. You'll get 4 over 3 x to the power 1 plus half. This is 3 over 2. Negative 9 over 2 greater than or equal 0. Now multiply both sides by 6. So you'll get 8x to the power 3 over 2 minus 27 greater than or equal 0. So we'll get 8x to the power 3 over 2 greater than or equal 27. So we'll get x to the power 3 over 2 greater than or equal 27 over 8. Okay. So now you can consider the critical values. You will get critical value that should be 3 over 2 equals to 27 over 8. So at first square both sides. So it will be x cubed. Sorry, square root both sides. x to the power 3 over 2. That means if you cube root both sides, 3 will get eliminated from the power. So you'll get half now, x to the power half. So cube root 27 is 3 and cube root 8 is 2. So the critical value is x equals 9 over 4. So the range of values we will get in this case, this is x greater than or equal what? 9 over 4. That's the answer. Okay, next. For part B, the point P lies on C. Its coordinates is given. The line L is the tangent to C at the point P. It's a tangent. Okay. The finite region R, shown shaded in figure 3, is bounded by the curve C, the line L, the x-axis, and the y-axis. Okay, fine. Find using calculus the exact area of R. Okay. We need the exact area of the region R. Okay. So at first, let's divide this area into two parts. So using integration, we will find the area below the curve, area between the curve and the x-axis from x equals to 9 to 0. So we'll get the whole area under the curve. Then from that area, we will subtract the area of this triangle. Then we will get the region R. That's it. So for finding the area under the triangle, what you can do? At first, you need this x coordinate. How can we find out that? Okay, the equation for line L is not given there. We need to figure it out at first. So for the equation of line, we need the gradient. And already we have the coordinates of a point P. Okay, at first figure out the gradient. Okay, for part B, when x equals 9, what's the gradient of the curve? 4 over 3x. So 4 over 3 times 9 minus 9 over 2 square root of x. 9 over 2 times 3. So that would be 12 minus 3 over 2. So that would be 21 over 2. This is the gradient of the line L. We got the gradient. Now we need the equation. So line L, its equation would be y minus, what's the coordinates of point P? 940. Okay. Y minus 40 equals to gradient is 21 over 2 m times x minus 9. So the equation of line L is y equals to 21 over twice of x negative 189 over 2 plus 40. So that would be 21 over twice of x, then negative. This is 109 over 2. So we got the equation of line L. This is y equals to 21 over twice of x negative 109 over 2. Now we need the point where it is intersecting the x-axis. Okay. So at x-axis, we know that the value for y is 0. So if you plug in y equals to 0, then you will get 21 over twice of x negative 109 over 2 equals to 0. So we'll get 21x equals to 109 equals to x equals 109 over 21. Okay, so this is the point where the straight line L is intersecting the x-axis. So can you see the screen? Hello? So it's fine now, right? Okay. So find out the area under the triangle. This is A. Area would be what? Half times base times height. So height would be the y coordinate of 40. So half times 40 times the base. Base is, what's the x coordinate? 9 minus 9 109 over. So this is the area of the triangle. Okay. So you will get, so this is 1600 over 21 unit squared. So we got area under the triangle. Now our work is to find, using integration, the area between the curve C and the x-axis. So let's integrate the curve within the fixed interval 9 to 0. So area under the curve. Integration, upper limit should be 9, lower limit should be 0. What's the equation of curve C? 2 over 3x squared, 2 over 3x squared negative 9 square root of x write 9 x to the power plus 13 dx. Now integrate just. You will get x cubed there. One get added with the power, and then divide 2 over 3 by the new power. Get 2 over 9. So x to the power half. Half plus 1, this is over 2. So 9 over 3 over 2, this is 9 times 2 over 3, which is 6. Negative 6 plus 13. Upper limit is 9. Lower limit is 0. So 9 cube. 9 cube over 9, this is 9 squared, so 81. 81 times 2, this is 162. Negative. Square root of 9 is 3. 3 cube is 27. 3 cube is 27. So 27 times 6. Negative 162 plus 13 times 9. 117. Okay. So the lower limit is 0. So every term has x. So it will be what? The area between the curve and the x-axis 170 unit squared. Okay. Now the area of region R. That would be what? Area under the curve C 117 minus the area of the triangle. This is 1600 over 21. That would be how much? This is 857 over 21 unit squared. That's it.